Okay, so on this rewind, this was very similar to the exit ticket from the last lesson. So people are still making the same mistake in number 1. What do you have to do first in the top in number 1? 7 times 3. Why don't you do 8 plus 3 first? Because multiplication comes first. How do you know that that's multiplication? Yeah, the parentheses. There is no symbol, so you assume it's multiply. So that ends up giving you 8 plus what? Negative 21, which is going to give you negative 13. Good. What about on the bottom? Do the exponent first. What's negative 3 squared? Positive 9, because a negative times a negative gives you a... When would this be negative? If the exponent were... If it didn't have parentheses or the exponent were odd. Very good. So if it's odd, then it becomes a negative. If it's even, it stays positive. Or like David said, if there are no parentheses, it's always negative. Okay? So 9 plus 4, which is what? 13. Good. And then 13 divided by 13 gives you negative 1, because 1 negative and a positive make a negative. Okay, what about number 2?
63.
All right, we do what's inside first, and we get the square root of, what is the square root of 64? Why do I know, or how do I know that that's multiply? There is no symbol, so we assume it's multiply, so that gives us 16. Okay, good job. All right, so what we're going to talk about today, we're going to talk about 3 properties of addition and multiplication, and then we're going to talk about combining like terms. And the focus is going to be on combining like terms, because that's the more challenging part of this lesson, okay? How many of you guys have heard, I'm not going to quiz you right now, just raise your hand if you have heard of the commutative property, the associative property, and the distributive property. So maybe you heard of them. Okay, and you've probably learned them at some point, but maybe don't remember. Commutative property is just a fancy way of saying that order does not matter. In addition and multiplication, 7 plus 2 and 2 plus 7 will both give you what? The same answer, which is 9. So they're both going to give you 9. Same thing with multiplication. 3 times 9 is? 9 times 3 is? 27. So they're both giving you the same thing. So commutative property tells you what can you do with the order of things. Flip it and it doesn't make a difference, right? Does that work for subtraction and division? No, why not? Give me an example of a subtraction problem. Any subtraction problem, make it easy. 17 minus 2, which is what? 15. If I flip that, what does that give me? Is that the same thing? No, those are complete opposites. Those are opposite numbers. So it does not work for subtraction, and it also doesn't work for division. Because division would be like 15 divided by 3 gives you what? 5. But 3 divided by 15 gives you a what kind of number? Some type of decimal that I'm not going to figure out right now, right? But some type of decimal number, okay? So commutative property, when the order of the numbers changes, that's how you recognize it. What is the associative property? What is the associative property? What's happening if you take a look right here? What's happening here? You have 6 plus 8 plus 2 and 6 plus 8 plus 2. Does that look exactly the same? No? What's different? The parentheses. So you've got a different grouping. So associative property is when you change the grouping. But does the order change? No. So commutative property is when the order changes. Associative property is when the parentheses change. All right? So parentheses change, but the order stays the same. So that's what's really important here. Because that's the easiest way to tell the difference. So the order stays the same, and in commutative, the order changes. All right, because sometimes there will be parentheses in commutative problems, so you shouldn't really look for just parentheses. You should look for the order of the numbers. So in commutative property, the order changes. In the associative property, the order stays the same. All right. Now, why do we care? Like why? Because you guys have heard it before. Like everybody raised their hand, oh, I've heard of the commutative property. And maybe you could tell me what it is, but why do we care about it? What does it do for us? Because if it doesn't do anything for us, then there's no reason to learn it. So what does it do for us? Take a look at this first one. If I just go left to right, what's the first thing I'm going to do? 4 times 9, which is what? 36. Then you would do 36 times 25, which tell me what that is right now. Spoiler. All right, let's pretend he didn't say that. All right, so no one got that one because you don't know that off the top of your head, right? Except maybe Jesse. All right, so you don't know that one off the top of your head. But if I switch the order of that, what's 4 times 25? 100, and 100 times 9? 900. Now everybody said, and not just Jesse, right? So that's 900. Is it easier in that order? Yes, it's easier because you don't have to do 36 times 25, which maybe you could do in your head, or you could pretend it's quarters and like count up quarters, and that's fine too, and you could do it in your head. But what property did we use to do that? The commutative, because what did we do with the order of the numbers? We switched them, and because it was multiplication, does it change the answer? No, both times the answer was 900. It's just easier to find if you do it in this order. So you might do that already. Like how many of you guys, when you're adding large groups of numbers, let's say you're doing like 18 plus 17 plus 12 plus 13. If you're adding these together, how many of you guys would group them like 8 and 2 together and 7 and 3 together? Why? It's easier because 7 plus 3 is 10, and 8 plus 2 is 10. So how many of you guys just do that naturally? A chunk of you, right? How many of you guys are like, well, let me apply the commutative property so I can switch the order of these? Probably none of you, right? But that's what you're doing. That property that lets you do what you did right here to group those together differently is the commutative property. So we're just putting a name to what you guys are already doing. So what could I switch here that might make this easier? 25 and 75, because that adds up to what? That adds up to 100, plus 48 is what? 148. Could you have gotten there if you kept it in this order? Absolutely. You definitely could have. How many of you would have needed to write it down instead of doing it mentally? I would have. I would have definitely written that down. Okay? But I know mentally 25 plus 75 is 100, and once I know that, 100 plus 48 is pretty easy for me to do mentally. So again, the whole point of the commutative property is to make your life easier. It's not to make your life harder. So if you don't want to switch the order of things, don't. But you do need to recognize when it's happening. All right. What is the distributive property? So don't look down here right now. Look right here. What is the distributive property? What are these arrows here? Jesse? Okay. So if you have 3 parentheses, 4 plus 8, you can do that 2 ways. You can either do 4 plus 8 first, which gives you what? 12. So that would be 3 times 12, which is what? 36. Or you can do 3 times 4, which is, and then 3 times 8, which is what? So then you can do 12 plus 24, which also gives you 36. Okay? So the distributive property tells you that you can either do this as an addition problem and then multiply, or you can do your multiplication first. What does it mean to distribute something? Like if I say we're distributing snacks after school, what does that mean? Yeah, we're giving them out, right? So basically I'm giving out this 3 to everything inside the parentheses. And the reason that you do this, because you don't usually do it when it's just numbers. Like usually you would do 4 plus 8 first because it makes it easier in your head. But if you have something like this, we can simplify this the same way. So I would do 5 times x, and I would do 5 times 7. How do I write 5 times x? 5x plus, what's 5 times 7? 35. So that's distributed. That's simplified because it's expanded out. Okay, so that's where we see the distributive property. Again, though, why do I care about it if it's not going to help me and make my life easier? So take a look at this problem right here. Do you know off the top of your head, if you do, don't, because it'll ruin my spiel. But do you know off the top of your head 15 times 103? No, maybe not. Okay, but could I break this up so it was a little bit easier? What addition problem could I break this 103 into that would make them like rounder numbers? 100 plus. Can you do 15 times 100 in your head? Yeah, what is it? 1,500, because if you multiply by 100, you really just add two zeros. Can you do 15 times 3 in your head? What is it? And now can you add these together in your head? All right, so I might not have been able to do that mentally. I probably would have had to write it down. But if I break it up into like a round number and then what's left over, then it makes it a little bit easier if I use the distributive property. So what could I break 19 into? 10 plus 9. Good. So 6 times 10 plus 9. And then if I distribute that, what's 6 times 10? What's 6 times 9? And what's 60 plus 54? 114. Again, if this doesn't make your life easier, don't do it, but be able to recognize it. Jesse, what were you going to say? Yes, absolutely. So there's another way you can do this. Instead of adding, you could do, Jesse, what? 20 minus what? 20 minus 1. Because what's 20 minus 1? 19. So we need it to give us 19. Okay. What's 6 times 20? And what's 6 times 1? And what's 120 minus 6? 114. So you can do it either way. David. Yeah. Mm-hmm. Like if you would just rather do 19 times 6. Yeah. But I want you to be able to recognize it. Okay? So again, if it doesn't make your life easier, don't use it. But if it does make it easier for you to do something mentally, just be able to recognize it at least. Okay? So what happened here? Why was this one 10 plus 9? This one is 20 minus 1. Either way, they have to give you what? 19. So in some way, they have to give you 19. Could you do like 23 and 4? 23 minus 4? Yes. Does that make your life any easier? No, because I still don't know 6 times 23 off the top of my head, and I know 6 times 4, but I don't know 6 times 23. So again, the whole purpose is to find numbers that make your life easier. So like the 10 and the 20 make your life easier because you can probably do those mentally. And again, if you can't do them mentally and none of this makes your life easier, then don't use it, but be able to recognize it. Okay, so distribute, like Emmanuel said, is give out, right? So hand out. So I'm handing the 6 out to everything. When you will use it all the time is in a situation like this, when you have a variable in there. Because you're not trying to solve this one, you're just trying to simplify. Okay? So simplifying means getting it down to like as simple as we can. Okay, we're actually just going to do these together. So you guys aren't going to go to your boards to do this because last time I did, it was like, it's too easy and it just is too quick. So if I want to use the commutative or associative property here to complete this statement, let's go ahead and do that. So negative 12 plus 6 would be equal to 6 plus, all right, what property is that? Good, these are actually all commutative. What would I do to fill in the blank here? 8 plus negative 4 is equal to negative 4 plus 8. Negative 6 times 3 is equal to, and negative 12 times 6 is equal to 6 times negative 12. Good. All of those were the commutative property. Let's take a look at 10, 16, 19, and 20. Remember, commutative property changes the order. Associative property does not. Okay, so the order stays the same. So what property is this? Commutative property. So this is the commutative property. I'm going to abbreviate it COMM because 7 and 8 flip spots. What about this one? Okay, gut reaction is associative. Why? Because you saw parentheses. Did the order change? No, so the order doesn't change, so it's associative, because what's in the parentheses here? 2 and 9. What's in it here? 3 and 2. So the associative property is when what's inside the parentheses changes. All right, what about this one? This is the commutative property. Why? The order changed, but what was inside the parentheses, did that change? No, it was still 1 plus 35. All right, and then down here, what property is this? Distributive. Why? You're handing out the 7 to everything inside it, right? So this is the distributive property. All right, because I took the 7 and I handed it out to the x and I handed it out to the y. So the way you can recognize distributive property is on this side, there were parentheses, and on this side, what? There are none. They go away. All right, the distributive property is essentially getting rid of those parentheses. Okay, so let's talk combining like terms. Before we talk about combining like terms, what does that mean, like terms? The variable is the same. Okay, so the variable has to be the same. And what else has to be the same? The exponent. So a variable and an exponent has to be the same. No? Okay. All right. So in this first one, we'll call it A. Are these like terms? Okay. You can only add and subtract if things are like terms. If they are not like terms, then you cannot add them or subtract them. So these are like terms because what's the variable in both of them? X. What's the exponent? There isn't any, so what do you assume? If there is no exponent, you assume it's to the power of 1. You assume a 1. You don't need to write it in there, but you can. It's to the power of 1. So those have matching exponents, so then can we add them together? Yes. So how do you add those together? 12 plus 30, that's it. 12 plus 30, which is 42, and then your term stays the same, so it's still just x. So 12x plus 30x gives you 42x. Okay, in B, what do we have in B? Do we have like terms? Yes. Yeah, because what's the variable? Y to the second and y to the second, so they match, so those are like terms. I don't see anything in front of here, so what do I assume that it is? A 1. So now I have 6.8y squared minus 1y squared. So what am I going to do? Subtract. What's 6.8 minus 1? 5.8. So my answer is 5.8 y squared. The variable does not change. Just like when you're adding and subtracting with fractions, if you have a common denominator, the denominator stays the same. Same thing here. Your variable does not change. All right, and last one here. Are these like terms? No, why not? One of them has an exponent of 2. The other one has an exponent of 1. So even if the variables match, those are not like terms. So there's nothing you can do that's already simplified. Right, so those are not like. I'm going to skip this, but I want to do one more example together. So find somewhere that you can write this down. Okay. If I give you this, first of all, how many terms are there?
2.
Alfonso? Why? this is a term, right? And there's 5 of those. Okay, so a term means variables and exponents and numbers held together by multiplication. So this is one term right here. We look at this as one thing. Are there any like terms in here? Yes? Which ones? The 5 is like the 4. Good. The 5 is like the 4. So when I do these, when I'm combining my like terms, I always use like, if I have a different colored pen or pencil, I would use that. But if I don't, I just underline them differently. So this one is like this one. Is it like anything else? No. Why not? It looks a lot like this one. The exponents are different. So here we have to have an exponent of 2 with the x and nothing with the y. Okay. Is this one like anything else? Which one? Okay, so I'm going to double underline that. And then this one, does it have any friends? No. So I'm going to triple underline that, or you can just leave it. All right. And now when I combine them, I'm going to do my one lines together, then my double lines together, then my triple lines together. So when you do these, look at the sign that's right in front of the term. So this one is a positive because there's nothing in front of it. And this one is also a positive. So we're just going to do what with them? And that gives us, good, 9x squared y. Now I'll do my double underline. I've got what here? Positive 3. And over here I've got a negative 8. So plus 3 minus 8, the signs are different. So what do? Subtract, which ends up giving me positive or negative 5? Negative 5. So negative 5xy squared. And then last but not least, this guy with no friends, he just goes on the end. And that's it. That's our combining like terms. So some of them are really simple and they're just 2 terms like 5x plus 6x, and you would just say, okay, that's 11x. Some of the ones we're going to do are a little bit more complicated, and that's where I really do recommend underlining or boxing or like some type of symbol. So you could be like, I'll put all these with an underline. I'll put these inside a box. I'll put these inside a squiggle. Like something so that you can differentiate between the terms that are like terms. And remember, keep the sign with the one that like the one that's in front of it. Okay? So the 3 goes with the plus, the 2 goes with the minus, the 4 goes with the plus, the 8 goes with the minus. So the only one that shouldn't have a sign is the first one unless it's negative. Okay, you guys have about 13 minutes to do these 8, which seems like a lot, but be careful with them. If it's easier for you